Hello all, welcome to the Nullcon webinar series. My name is Harshit, I'm a part of Nullcon team. We have been running Nullcon Security Conference since 2010, where cybersecurity is discussed in detail among the industry, government and tech community. This pandemic has given us the opportunity to continue to share knowledge and connect with our global community by running lots of online events like conferences, webinar, workshops, training and resume clinics. In the coming time, there will be some exciting webinars coming on the way on malware and enterprise security. One quick announcement is we have also launched our annual Nullcon International Security Conference and Training 2021 in the online version, and which is scheduled from 1st to 6th of March. Do check out more details in the chat window. Now about today's webinar. Today we have with us Merab Tato Kutalia, and he's presenting his talk on defensive programming versus fintech. Merab is a software engineer with 8 years of experience specializing in Android development. He is a fan of all things of software development, particularly architecture, with a penchant for exploiting potential of the platform. Out of work, Merab maintains an active podcast about work ethics and career growth, writes tech blogs, and is a GDG organizer and speaker at international meetups, conferences, and beyond that. So on behalf of all of us, I welcome him to this session. Before we go ahead, a few quick announcements for the audience. Our today's talk duration will be for 30 minutes, and after that we will have a question answer session. So you all can ask your question using the chat option of Zoom, and they will be answered after the talk by speaker. And also I request you to keep your mic mute during the session. So without any further delay, I request Merab to take a charge of the session. Thank you.
Hello. Hello everyone, and it's very welcoming that I'm at Nullcon, and it's a great pleasure for me, and thank you for this again. So today's topic is defensive programming and fintech, and this is a point, the fintech mostly, that I want to underline, and I've seen numerous of mistakes and also like errors in FinTech Android applications, and that's why the topic and the concept of defensive programming is I want to speak about. So mostly defensive programming is not widely used in the industry because the opposite of this, the fail fast methodology is used. But I want to assure you that enterprise grade applications and enterprise grade systems, sometimes defensive programming works better. It's not the must that you should use defensive programming, but sometimes it works better. And so let me guide you to express all these little details about this paradigm, to maybe it may interest you and use it later. So I'm Tato Kutalia, Android software engineer and chapter lead at Tbilisi Bank, one of the largest banks in country of Georgia. So you can find me on any social network on this website, TatoCaster.me. So remember this quote until the end of this session, because it will make more sense then. So defend against the impossible, because the impossible will happen. It's like Murphy's law. So, but for this session, you should remember this, and let's talk this about later. So why should we defend against the impossible? What are the odds that impossible will happen, and what are the safest way to do these things in programming in Android platform or any other platform, and how we can defend ourselves and the project? So let me show you the picture of the well-known USB port. USB actually, yeah, it's port, external bed designed, and there are multiple ways to plug. Even 10 years of experience, you can still plug it in the wrong way, and it's like in programming, you need some kind of experience, for example, 2 years, 3 years to master one technology, and then you feel quite good at this technology. But with this USB port, no, you can't. Even after the 10 years, you can still plug it in the wrong way. But on the other hand, we have a really good design like the HDMI plug. Why? Because you have only one way to plug it. You either plug it or not. If you can't plug it in this port, it means that it's a wrong hole. So only one way to plug it. So actually, this is a really good design. So the whole speech and whole session during today, it will be like this. What are the bad design decisions and what are the better design decisions that we can adopt? So before I start the main part of the session, I want to share these books. I guess most of you know it, but it is not only intended for Java developers and the Java software engineers. Any software engineer can read it as very specific paragraphs, but those are the books that you should keep nearby and always access it and always try to understand how you can do better job in your daily work and with your design. I mean system design, and working effectively with the legacy code, the iconic books and the must-read books. So after you read those books, you see the software development and this whole chain with a quite a different angle, because you know the price you pay for any decision you make. So that's a very clear point you get from these books. Okay, what happens when you discover some kind of unexpected bugs that you didn't expect until then? It means that the first option is to add some kind of validation. So, okay, if this is not null, or maybe if it's more than 0, I'll do this, and else I'll do that. Maybe it's some kind of error handling. It's like you expect some kind of HTTP call to finish, and on an error you roll back something, you show some kind of error dialog for the user to not break the UX for the whole project. And another option is to add logging, because you need as much information from production as you can. So this is a mandatory step, and you get the code that should have been there in the first place. So it should be natural that you should write validations, you should write error handling, even the try catch, and you should try to catch this exception and the log exceptions in anywhere in the local system, maybe in the third-party cloud provider, no matter where. But the key is you should log it in the accessible place. So those three parts are essential for any software design. So this is the code you should write in the first place, and not the vice versa, that just write the working code and then add toppings on it, and then after some iterations you will get the spaghetti code and not well designed, tangled. You break solid principles and so on. So mostly you should aim to do all these little things together. And because of those mistakes, and during my career I've seen lots of them, and even I wrote a lot of them, and so combined all experience gave me some kind of motivation to write down some suggestions. It's not a rule. They're just suggestions how we can approach better code, better software design, be a better teammates, and we can provide good pull requests to the team, because it will be easier to review, and also the overall project health will be better. So from those suggestions, first is the safe zones. What does it mean? So our code should should invalidate everything coming from the outside of our project zone. Like we should create some kind of boundaries, what we trust and what we don't trust. Like any user input should be validated, and it's a danger zone. So this is the barrier that we don't trust. But on the other hand, we may trust, and we should trust, third-party dependencies. Yeah, So if I add the Facebook SDK as my third-party dependency, I trust Facebook SDK that it will work as expected. Majority of time, not always it works, but majority of time you expect that it works as intended, and you assume that it's not in a dangerous zone and it's safe to use. But on the other hand, you don't trust any user input, you don't trust any network request, and you validate it, and you try to keep your core, the main domain, in a safe area, and create these boundaries around it. And then we need to do the double checks. For example, any image upload functionality in mobile phones, websites, I don't know, everywhere. We should check for limits and bounds, for some MIME types, maximum size, minimal size, also the content, headers, and stuff like this. So we should do all those checks, because if we create those rules, we shall not break our rules, and we are saying that, okay, this is dangerous and we don't trust any of it. Because if we trust anything from it, it means that it's happening and you break your own rules, and it's not acceptable. Especially it's not acceptable in big teams. For example, if you're a solo developer, okay, maybe you plan the whole project in your mind, and you are the one who's creating those projects, and you are capable to change some things quickly. But where you are in a team, 5, 10, 15 developers, in a project, and maybe in the agile structure, when there are multiple teams synchronized together, you can't create pull request with this kind of code, because it will be rejected. You waste other people's time and you waste your own time. So there are some standards in the project, and you have to respect it. And yeah, I want to clarify that to the whitelist, it's like the yellow list. So, and not the block list. So you should block everything by default and only allow what you want, because this is also a very popular decision and design in the security and cybersecurity field, and same in the software design. So you block everything and only allow very specific code or any specific inputs in your application. So what about the handling? Okay, defensive, you may say that defensive, okay, if we are talking about the defensive programming, it means that, okay, we should hide every exception, we should hide any error in the application that may happen in runtime, but it's not like this. Defensive programming is not all about this swallowing errors and hiding bugs or any of it. Defensive programming is not to break the user experience of the overall user experience of the project, of the application, and we still get all the necessary information from the system. For example, if we break, so something may happen in runtime, maybe null exception, null pointer exception, or some size checks, and application may just crash. The Android application may just crash. It's not very good UX for the people, and especially if your user base is more than 500,000, maybe, or million. So imagine that Twitter application or Facebook application or Google Mail, Gmail application breaks. So you get crashes. It's annoying, yes? So, and especially if you are working in a financial fintech field, it's very annoying. It breaks the UX. It means you lose your customers and you get lots of bug reports and complaints. So instead of this, why don't we make handling more exceptions log everything, embrace that we failed, we create bugs, we embrace it, but we try that the customers should be happy, still happy and enjoy the application, maybe show some respective error message, and okay, we will fix it later in the next iteration, but we don't crash the application. But on the other hand, there are some domains in software engineering and in overall in business, there are some domains that fail fast methodology is better, that you want just to crash your application, to crash your whole system instead of getting any invalid value or stuff like this. This is a way of communication, and both of them have some pros and cons. So it's up to you which discipline you use. You can mix some of it together, but those are the suggestions I have for the defensive programming. So one of the methods to avoid avoid the unexpected behavior of the system is to return natural value. I'm not always a fan of this method, but it still exists, mostly in dynamic type languages like PHP, because sometimes they can return just the empty string instead of other value, and instead of crash, they just try to return empty string and then check elsewhere. If it's empty, okay, do this. If it's not empty, do other thing. So this is one of the common ways also to approach the and do one step forward to defensive programming. And as I said, don't afraid to fail. We all create bugs from day to day, even the bugs that we can't find, we can't understand, especially in the concurrent application, multi-threaded application, where the system design is already complicated. When you work with the threads, you have already a complicated problem. When you work with the regex, sometimes you already have a problem. So embrace that we can fail, but let's not fail for the customers. Let's not break this behavior for the customer. So that's what the defensive programming may help you. Okay, as a point when I mentioned in the earlier slides, the Facebook SDK, it works most of the time, but not always. So that's the case almost here. So you should not trust the code that it should work as advertised, because this code is also written by the developer, by the programmer like you. So it's like you may know how to drive a car in a city very well, but there are also lots of other drivers who don't, and they may crash to you. You try to avoid any crash, but still it may happen, and they may crash to your car. So that's a problem here. You may write the code you want and very clean, in a clean manner, and also do all the validation stuff, but still you have third-party dependencies in your app. Still you have other people's code in your system, maybe from the other teams as a maybe jar dependency, maybe some old team members wrote it, maybe also from the GitHub or any other third-party system. So the strategy for this is to always wrap third-party libraries separately and use it with our own gateway. So remember that we created some safe bounds for user validation, the inputs. Okay, now we should create another layer that we don't trust some code in our system. So because of this, we create the wrappers for any of the dependencies. And actually, this is a very standard, very common, popular way of this software design. For example, you have image loading libraries that you chose and you like it. It has a really good caching mechanism, and you try to use it in your project. But after some time, you understand that it is not the quite good library that you need. So you want to change it. So if you used it just in your project simply and use it in 15 different places, you need to change those 15 different places again with the new library. Or again, you can wrap this library, you can create one extra abstraction layer and use this abstraction layer everywhere from the code. And you have only one implementation of this library. So when it comes to change this library, you only change in one place, but the contract you have with with other classes, you don't break it. So that's a common way of the software design. But on the other hand, besides the design, it's the safest way to use other people's code, actually. So that's why always try to wrap everything and use it via some interfaces, so expose some kind of interface, or maybe create some other data structures to expose it to the rest of the system. And you should do this always. Also, I want to underline this point, the assertions point, that you should always check for the impossible cases, for like sometimes you don't expect, according to the documentation, that something may happen, or because when you have this tech documentation or something like this, maybe there are not all the cases included. So you need to assume that you should cover any base cases for application, because you don't want to break your application or in a business domain. So like when you get HTTP response after the request, you should expect that some fields may be not nullable. Even if the documentation says that it will not, you should always you should always write it as nullable, because it may happen. You don't know. It may happen. Maybe some problems on the backend, maybe something may change on the fly. I don't know. Anything may happen. So you expose it as a nullable and then map it in your internal system and check it. And in the actual business domain and the business logic, you have other kinds of models already mapped to this set, which are not nullable. So keep in mind to get as a nullable and then transform it to internal models. So here is an example of just a mock example of the Facebook client to get some user by a token. So this is the example how we expect that email validation, sometimes the email may be null. This may happen even in an interesting example, that if the Facebook library is written in Java, Java may return null and instead of the string. And in the Kotlin, if you use this, you don't have any clear indications that it will not be null, and you need some kind of annotation. So it's always best option to validate it and check against it, and then throw the exception if it's necessary. If it's not then necessary, okay, just log it somewhere and return. But I prefer to throw exception here, because it will be like the base layer with many different places use it. So throw exception from here, and the consumers can handle it and then log it accordingly. And it depends on the use case. So speaking of logging, as I mentioned, you should log it everywhere as much as you can. And for the logging, you can use, for example, for Android and for web, Crashlytics, Firebug Crashlytics, Sentry. Also, there are many other cloud providers which actually help you to log it, and they even provide a very nicely packaged SDKs for it. But you can also create your logging providers. Also, you can log it in a system everywhere. Just log it. Keep in mind that also if you do on a device level logging or the system level logging, I don't know, keep in mind the security risks, and always access all the software decisions with the security in mind, because there are potential holes everywhere when you may not be aware of writing it, but research it on the internet and try to understand how the security principles work together with the software design. And actually, both of them together create better decisions and better products which are safest for the user. But this is a topic for another talk, but some don't go too far, because security and software design sometimes break the UX design. So security in mind means sometimes users need to get much worse user experience, because still sometimes just paper and pen is the best secure way to do things instead of I don't know, IOTs and other stuff like this. So speaking of errors, let's take a step back and analyze what kind of errors might our application get. So there are actually two, we can divide in two categories. One is a normal error that you expect that there can happen any error, and another one is that the expected errors that can crash your application. So because of this, not all errors are the errors. Consider this that HTTP request and response errors are the errors that you should expect. So, and you respectively validate it and check for it, and it's in standard business flow. You either process it or show some kind of error message or I don't know. So that's a normal. But on the other hand, sometimes HTTP request may fail because of the broken internet connection, maybe some kind of certificate because certificate is compromised, or I don't know, the server outage. Anything can happen. So this is another type of error which you should handle a different way, and you need to log this exception. You may not log it the standard error code failed HTTP request, but if you get the exception of it from it, and if it's actually failed from the system, so you need to log it and handle it in a different way. So this is just an example with the types. And yes, there are all the mixed little suggestions here that you should have some kind of timeout strategy. It's very obvious, I guess, but still I've seen numerous of applications that fail to adopt this technique to some kind of timeout strategy. So you should not wait for the call to finish infinitely and retry timeout, retry logic to maybe this call, maybe this some very specific call is crucial to you, so you may not fail on the first try and try again. Maybe you need you add some kind of timeout and you try again in 2 seconds, then in 5 seconds, and again in 8 seconds, maybe some kind of strategy. It all depends on a business decision, and it all depends in what domain you are working, because as I mentioned, that sometimes fail fast is a preferred strategy. So, but keep in mind that working with the networks, that the best way is timeout and retry logic. And now I wanted to talk, this one always annoys me, that for the null checks, mostly in Kotlin and Android developers, they use this Kotlin preference, the let, instead of just checking for the null if it's not null. This is for immutable variables. And let me show you quickly what I mean. So it's a Kotlin actually. In a Kotlin, when you have this immutable variable, sometimes they like to write in a more Kotlin way that okay, something dot let, and in the braces you can write already the code, and you expect that it will not be null. But actually, when you decompile Java, you get pretty different code, and you actually didn't mean it to write it, because normally you wouldn't write this code. So it means that it creates another variable to overcome this Kotlin magic. So always it's the better manner to approach this is to, for the immutable variables, please try to use just null checking. It's okay to use in a Kotlin. It will not make you a Kotlin hater or any other. Just check for the null for the immutable variables, but for the mutable variables, okay, you can use let. This was a part that very annoyed me in many Android applications. And also, when I was talking about the security, keep in mind that the security plus the software design can create actually good products. And this part is the basics of the security, this cybersecurity, but sometimes abused in software design, mostly junior and middle developers, that they just simply save and keep the password in memory as a string, but actually string may leak in memory because they can be distracted, and every time you pass it to another method, it's like it creates another copy. Unlike the char and byte, these primitive arrays that you can overwrite in memory, and in a very short time you can just pass it whenever you need and where you need, and then you can clear this array again, and you limit the in-memory access for intruders to steal your password. This is a very niche stuff, very specific task. But if you work in a fintech and if you work with the credentials, user credentials, keep in mind that using string is not the best option, and you should opt in for the primitives. And if you need more information about it, you can always search for the OWASP top 10 for the mobile or for the web, and you can always research those basic security topics around it. So now let me talk about a little bit about the Kotlin, because mostly I'm a Java developer. The fintech applications and all modern applications especially use Kotlin nowadays instead of Java, and there are some consequences in Kotlin that all the Java developers are aware of, and they have very good experience with it, but the newcomers sometimes abuse this Kotlin sweet syntax and don't use the proper code checking for it. The first is Kotlin has unchecked exceptions. It means that in Java you used to add this exception in the method signature. So okay, this method throws this kind of exception, and in Kotlin you don't have like anything like this, and you should put annotation on top of the function to provide this understanding to the consumer code that okay, this method, this function may throw some kind of exception. And also check parameters instead of try catch. So mostly in Kotlin, they don't use try catch. I've seen the applications that in most places try catch is better solution, but no. And as I mentioned, in Java, sometimes those decisions are better exposed in Java, because Java is more a verbose language for it. And you can always check those kind of stuff as decompiled Java or in a Kotlin bytecode. You can just in IntelliJ ID, you can always tools Kotlin, show Kotlin bytecode, and always check out the generated code you have. For example, like this code snippet, you have some kind of file to string. So in Java, there would be a signature in the method headers that it throws IO exception. But in Kotlin, you don't have it. it still throw exception. It may still fail, but you don't get anything in the code. So it's always better to put the annotation on top of it. Okay. I want to I want to show this quote. It's actually from the Stefan Friedrich, and I've seen it in a PHP community actually, and I really liked it, and I wanted to include in this speech. So a public method is like a child. Once you've written it, and you are going to maintain it for the rest of the life. So what does it mean? It means that when you create this public contract, public API, and some other people are the consumers of your code, you can change it anymore. So for example, imagine the in Java class in the Android. So I mean any class in the Android SDK and with a public method, and in the next release they removed it. No, it's not gonna happen. That means that they should maintain it for the rest of their lives. Maybe they can deprecate it and after 3, 4, 5 years remove it, but it's a very long process, and I don't remember any function removed from Android SDK. I remember all the deprecated stuff, but not removed. So it's like this, even for your code, if you are a library developer, if you create some kind of SDKs, it doesn't matter. If you create the public functions, public methods, you should always keep in mind that you need to maintain it until the end. So this is a very nice code. I want to share it. This whole part of my speech was why defensive programming is good and how we should adopt it. But what are the limits? Yeah. Well, when we think that, okay, it's too much because there are no clear boundaries between them. You don't have like 1 and 0. You don't have the clear distinction between those two. So how we should adopt some kind of mechanism, strategies to don't go too far. So everything depends on the team of the developers, and everything depends on your culture. The company culture, developer culture, because the defensive code is still written by you, and all code has bugs. So it means even if your defensive code can still have some kind of bugs. So understanding what conditions to check and how much and what to look in a code, it's as I said, it depends on your team, and it takes experience. Like in an agile culture, in a newly created agile teams, they don't know what the story points are, what is their velocity, how they can do a better job together, and over time they practice and they create those rituals, those standards in their mind, and they're much agile and quick in their processes. The same applies to your development culture. So defensive code means that you can write down some kind of rules. Okay, we accept this, then create some kind of linter rules, static code analysis for it. And okay, we accept this. Every code should have the tests, validations, all the proper Java doc on top of it, but not like the checks for the very extreme checks and stuff like this. So you should find the boundaries, and every time you finish the sprint or some kind of milestone, you can sit with your peers, with your other developers, and do a retrospective meeting that, so okay, we can slightly change our rules, we can make it more even more strict, and yeah, that takes time. And don't reinvent the wheel. So this is a key part here. Don't reinvent the wheel, because if you don't use frameworks, if you don't use any kind of framework, you lose the huge benefit of this, all the validation checks, all the defensive mechanisms, all the performance boost you get, and you're doing extra work for no reasons. And to avoid this, try to use some kind of frameworks which is already trusted. Maybe, I don't know, even if you create in the team, you should be aware that it should solve very specific problems that other frameworks can't, because 90% of use cases are already covered, and 90% of the checks are already covered, and the security part of this are already covered. So keep in mind that see what other people's write, what other people know, what are the use cases they went through, and then adapt it to it. So that's a smart and intelligent way, the code usage. The code reuse is not like to write some kind of utility class and use it in several projects on some kind of module. This is also a intelligent code reuse when you try to understand other businesses, other people's problems, other people's use cases, how they solved, and even without the basic code reuse, you can reuse their mindset, how they solved and approach this problem. So that's the intelligent way to cover your problems. I want to skip this, and I know that I don't have much time, but just to quickly recap. The overall defensive code, what are the overall defensive code? And just to be safe, sometimes in the teams, mostly new members write extremely defensive code that, okay, I just want to be safe, and I just want to be sure, 100% sure that everything will go well. So they passing empty objects, return any value, just not to crash it, crash the application, and they traverse any object, they check for keys, and they do all the jobs they don't need to do. For example, like this. So even this is from the Reddit. I found it a year or two ago. It's a very funny case that they try to cover all the use cases, just want to make sure that Deja font family will be there. They use asterisk in any manipulations, they use importance. So this is a code, and this one. So don't do checks like this. Even in a team, you should create some kind of other data structure or expect something from a backend in other ways. So doing those checks, and mostly in a whole application, it breaks the flow for other developers, and it's harder to maintain. And this one, always try to specify the exceptions you are waiting for. For example, generic exception. So okay, I write in Kotlin. I know that I should write annotation. Okay, boom, it throws exception. Now we handle it. Not a very good job. So specify what are the errors it throws. So number format exception, illegal argument exception. Always provide very specific exceptions for documentation, even add the Java doc for it. So the last part, the FinTech, mostly FinTech. So because I work in FinTech and I've seen many applications, I decompiled many applications, I tackled many applications. I've seen, I can't remember how many applications, but they don't use big decimals in their applications. I don't know why, but they use double, they use double for money. And then you get those kind of errors, you know, that you want to do some kind of arithmetic operation, and then voila, you have floats and you can handle it. And then you get wrong. And when you cast it to the string, you get not very good representation of it for the user. And then you try to round it up or round it down, all kind of mess. And why? Because when you can have the big decimal here, it has several options for rounding, it has a scaling, and you get anything from it. And it's a common approach, big decimal, and the preferred way is to create it from the string, and you can chop off all the trailing zeros. You can get the scientific notation, the plain string. So this is a part of the some kind of defensive programming. Also, from the doubles, you don't get any kind of exceptions like in this example. But the problem is that you are not doing the good job here. So the better way is to approach it with the proper tool like the big decimal and use it in an application. So this gives you more safer, nicer way to use over the numbers. And always before going into the task, try to research what are the best ways to solve this problem, and how other, maybe even you need to decompile other application, I don't know, just to understand how the logic works. Yes, this is a way. So this is a way mostly. Yeah, to summarize, did you remember the this quote I put in the first slide? I guess it's too far from here, but the impossible may happen. Yeah, that's right. So after this presentation, I hope it is much clearer for the audience that impossible may happen, and you should always defend against it. Yeah, that's it for me, and I'm happy to answer any questions. Okay, here are some questions, I guess.
So we have one question, Merab. First is thank you for this really amazing informative session. So we have one question from Saurabh. He's asking, solid design principles are known to help in writing cleaner and maintainable code. Do they help in writing secure code also?
Yeah, great question. Thanks. Yeah, it is. Solid is advertised as the proper manner to write the clean, maintainable, testable code, and every team should adopt it, and everyone can be happy with the solid code. Yes, but the security is also implied in solid, because when you write good design, it means that you write it the way that you can handle those exceptions, those errors in easier way. When you have less coherence, I mean less coupled code together, it means that you can smell bugs faster. It means that you can write tests for it, and more tests means that less security bugs you will have, and you can understand the code logic itself in an easier way, other than all the spaghetti code together. And solid, it's not all about the spaghetti, but the mindset, how you approach the code. So actually, it implies the security, and it's not always advertised as a security, because most software engineers don't think about the security first, even when they do some kind of authentication system. Mostly front-end developers, and mobile is the front-end, yeah? So they don't think about the authentication, how they can how to store some kind of user details in preferences in a secure manner and stuff like this. Those are the skills that needs time to acquire. So definitely solid will help a part of it, how you can introduce some kind of user validations and other layers in the code in a clean coding manner. And thanks again for this question. And another question is Kauka. Oh, okay. You said that we should not validate nested object for nested null checks that. How do you suggest validate the data? Yeah, nice. Okay, I said that mostly you should not do this, because it means that you have very tangled data structure, and maybe you can change how you get the response for it, or if it's an internal state, change the implementation, how you do and how you store it in your internal data structure, because most of the time it is not needed, and it can be broken in several pieces. The object for this, object for this, object for that, and you can reuse it. But I agree that sometimes in complex enterprise applications this may happen. But when I have this kind of case, and if it's a part of validation, we always have this validation explicitly in a separate place, and we try to create a layer, some kind of abstraction, clear abstraction layer between the business logic and all the data. So this kind of check is not okay in a business logic layer because it's too much work. And even for this, to scan the whole application, to scan the whole application, you can create linter rules, automatic checks in CI server as well, to prevent those kind of accidents later in the code. And these linters will throw error or warning, and you know that there's some kind of code smell. Actually, it's a code smell. It's not a security risk, but it's a code smell. And because it's a code smell, sometimes you may fail to validate all the all these properties, because for this properties, you need to check if the model is not null, if the prop is not null, and then check for subprop if it's not null, and if it's not empty string, and if it's equals for some kind of you do those kind of assertions. So that's why it's a code smell and a potential place to introduce bugs. But as I said in the beginning, you can avoid this, but there's a much better ways to reduce the risk of introducing those kind of code in the code base. Maybe this answers your question. Yeah, thank you.
Yeah, okay. So I guess we don't have any more questions, and we are out of time also. So once again, thank you, Merab, for this really amazing session and your efforts in delivering this session to our audience. And thank you, audience, for your participation in today's session. We have our next webinar session on enterprise security architecture by Neeraj Shukla on 19th Feb 2021. So hope to see you all there, and thank you again. Good day.
Thank you. Bye.